Hello, it is Miss Thompson here. We're going to talk about the real number system, classifying real numbers. This is indicator one, and let's get started. All right, so there's going to be different types of numbers, and we've got first thing we're going to talk about is natural numbers, and that's going to be 1, 2, 3, 4, 5, and then so on into infinity. Zero is not included here, and that's one thing you need to remember. Starting from 1 to infinity, all whole numbers are considered natural numbers. Now, next type of number we're going to talk about is a whole number. So we've got 0 now included, 1, 2, 3, 4, on into infinity, and negative numbers are not included here yet. Okay, so natural numbers, whole numbers, and then we have what's called integers, and that's where negative numbers can come in. So -3, -2, -1, 0, 1, 2, 3, and so on. So any negative or positive whole number is considered an integer. All right, let's talk about rational numbers. So rational numbers can be expressed in the form of a over b, where b cannot be equal to 0, and a and b are both integers. So you think about a rational number being a fraction. It can also be a decimal. So fractions can include 1/7, 3/4, or 5/9. Any of those, and there's infinite number of fractions that we could use. When we start talking about decimals, we're going to talk about terminating and repeating decimals, and these are considered rational numbers. So a terminating decimal are rational numbers in decimal form that have finite numbers of decimals. That just means it stops. So we're at 1.5, 2.75, or 4.0. So those decimals stop and they don't go on forever. Repeating decimals are rational numbers in decimal form that have a block of one or more decimals that repeat continuously. So 1/3 is actually in decimal form 0.33333, and then it repeats forever. So that's why that line is over 3, because it's a repeating decimal. Look at the next one. 7/11 is equal to 0.6363, and then that 63 repeats forever. So that is considered a repeating decimal, and that's a rational number. And then we look at 1/7 right here, okay? And look at this pattern. We've got 0.142857, and then it starts over 142,857. So that is a long repeating decimal, but it's still repeating, which makes it a rational number. You can also have irrational numbers, okay? And this is where it cannot be expressed in the form a over b. Irrational numbers include square roots of whole numbers that are not a perfect square, or non-terminating decimals that do not repeat. So we could have radical 2. That is not a perfect square. And if you were to put that in your calculator, you're going to get a whole lot of decimals, and it's never going to stop. It's going to continue on and on and on and on. Pi never stops never stops going. They're still working on numbers that are in that series for pi. Radical 8, that is also an irrational number because that decimal repeats on and on and on and on and on. Okay. So what are real numbers? Real numbers are all the numbers that we just talked about, okay? So all numbers that can be expressed on a number line. So that's irrational numbers, rational, whole numbers, integers, natural numbers. Okay, so let's look at this little chart right here. So we've got natural numbers right in the center, okay? So there's our natural numbers. We've got 2. This simplifies to 3, 8, and then 1. And then outside of natural numbers, we've got whole numbers, okay? So now we're including 0 in that, but whole numbers are also natural numbers, okay? And then outside of the whole numbers, we've got integers, okay? So there's some examples of our integers, and integers are whole numbers and natural numbers. And then outside of that, we've got rational numbers, okay? So there's our rational numbers, some examples. And rational numbers are integers, whole numbers, natural numbers. Those are all included in rational numbers. Now, we've got real numbers right here. And remember, real numbers include irrational numbers and rational numbers. So here's some examples of our irrational numbers. And so that box is here. And then we've got something that's called a complex number. Okay, and this is something that you'll get into with Algebra 2, so don't worry about that, but you'll see this I right here, that's called an imaginary number. So can't you wait? You can't wait for that, can you? All right, so now let's talk about looking at these numbers above, which of the statements are always true, which are sometimes true, and which are never true. Okay, so the sum of a rational number and a rational number is rational. I want you to think about that. Would that be always true, sometimes true, or never true? Okay, let's look at B. The sum of a rational number and an irrational number is rational. So what do you think about that one? Always true, sometimes true, or never true? C, the sum of an irrational number and an irrational number is irrational. What about that one? Always true, sometimes true, or never true? Let's look at D. The product of a rational number and a rational number is rational. What do you think about that one? Always true, sometimes true, or never true? Remember, product means multiplication. E part, the product of a rational number and an irrational number is irrational. So the product of a rational number and an irrational number is irrational. Is that always true, sometimes true, or never true? And then F, the product of an irrational number and an irrational number is irrational. What do you think about that one? Always true, sometimes true, or never true? Okay, so let's look at our next slide right here. So the sum of a rational number and a rational number is always rational. So that's always true right there. So you're always going to get a rational number when you are just adding or subtracting rational numbers there. B part, the sum of a rational number and an irrational number is irrational. That one is always true, okay? So the sum of a rational number and an irrational number is always irrational. Let's look at C part. The sum of an irrational and an irrational number is irrational. That one is sometimes true. Let's look at the example from up above. Radical 2, and then we've got this negative radical 2. If we go ahead and add these together, that's going to equal 0. So that's why it is sometimes true. All right, D part. The product of a rational number and a rational number is rational. That one is always true. All right, now let's look at E part. The product of a rational number and an irrational number is irrational. That's almost true. Okay, so we've got 0 as a rational number, and when we multiply by any irrational number, that's going to give us 0. Okay, so that product is rational. So that one is almost always true, except when 0 comes into play. F part, the product of an irrational number and an irrational number is irrational. That one's sometimes true. Look at the example right here. Multiplying radical 2 and 1 over radical 2 gives you 1. Okay, so that one is almost always true, just like F. All right, guys, so that is it for this lesson. Make sure to do your activity and have a great day.